Assalamu alaikum, dear students. Welcome to the next lecture of structural analysis. In this lecture, I am going to discuss about moment area theorem. So, what is moment area theorem? Why we use moment area theorem? And what is the basic purpose of moment area theorem? Okay. With the help of moment area theorem, we can easily find the slope and deflection of the beams. Okay. Now, question arise in my mind: what is slope and what is deflection? Okay. Now, slope is also called rotation of the beam. Slope of the beam occur due to movement, internal movement of the beam. Okay, and deflection occur in the beam due to shear forces or normal forces, or we can also call vertical forces, which is acting on the beam. Due to this, deflection will occur in the beam. Now, in the real beam, how we can determine that this is the slope and this is the deflection? For example, this is the simply supported beam, which is supported by hinge support and roller support. So there is some UDL load applied, which is acting on downward on this beam. Okay, so this beam must be deflect downward due to this loading. If this beam is deflect downward, so the deflected shape of the beam will be make some angle with the original beam. Okay, so this is called the slope or rotation of the beam. Why this slope and rotation occur in the beam? Due to movement occur. For example, we consider this point. So at this point, this UDL load must be create some clockwise, some anti-clockwise movement. Okay, and from B point, this will be create anti-clockwise movement. Okay, along A point will be create clockwise movement. So they should be create a clockwise angle along with the horizontal line of the beam or original shape of the beam. Okay, now if we consider the deflection of the beam, so due to this load which is acting on downward, so at center there will be maximum deflection or maximum displacement of the beam. Beam displaced at from original position. Okay, due to this, deflection occur in the beam. Now our main target of our today lecture is how we can find these displacement or deflection and slope or rotation. Okay, basically moment area theorem provide us a simple solution for deflection and the slope of the beam. With the help of moment area theorem, we can easily find deflection of the beam and slope of the beam. Basically, there are moment area theorem. Basically, there are comprised on two theories. The first one is for the slope of the beam, and the second one, with the help of second one, we can easily find the deflection of the beam. So now we are coming toward the theoretical portion of moment area theorem. Okay, that how introduce who introduced the moment area theorem and when introduced moment area theorem. Okay, the initial idea for two moment area theorem were developed by Otto Mohr, and they are stated formally by Charles E. Greene in 1873. This is the scientist name of which have developed, which have discovered the moment area theorem in 1873. Basically, this theorem is introduced in 1873. This theorem provide a semi-graphical technique for determining the slope of the elastic curve and its deflection due to bending. Okay, with the help of this theorem, we can easily find the slope and deflection of the beam. But how? This is the semi-graphical technique. Okay, for example, the bending moment diagram is a graphical method. So with the help of bending moment diagram, we can easily find the slope and deflection of the beam. They are particularly advantageous when you solve a problem involving beam, especially those subjected to series of concentrated loading and having segment with different moment of inertia. Okay, if in the question different moment of inertia, for example, from support A to center of the beam, moment of inertia having different value, and from the center to this support, the moment of inertia having different value. So in this situation, the moment area theorem will adhere, and with the help of moment area theorem, we can easily find the slope and deflection of at any particular point. Okay. To develop the theorem, reference is made to the beam and figure 8.14a. Okay, this is figure in 8.14a. Flexural rigidity EI. Okay, what does it mean by flexural rigidity? Flexural rigidity means that EI. Now, what does it mean by EI? E mean modulus of elasticity, and I mean moment of inertia. Okay, so the combination or the product of moment of inertia and modulus of elasticity is called flexural rigidity. Okay, the M by EI diagram shown in the figure, you can see here, this is the M by EI diagram. What does it mean by M by EI diagram? First of all, we are needed to draw the shear force diagram for this beam, and then we will draw the bending moment diagram. Then bending moment diagram, every point of view. For example, this is the maximum moment 800 kip. So we must be divided 800 by EI. EI value must be given in every question of structural analysis. If not given, we can easily find with the help of cross section and with the help of different dimension of the given beam or the given structural element. Now, d theta, if we are find, for example, at horizontal distance theta, okay, so this should be equal to m by a diagram and dx. Okay, so we take a derivative of this with respect to dx. Dx means that horizontal distance. Now, uh, our target is to find the moment area. So, integration we use for area. Thus, it can be seen that the change in d theta is the slope of tangent and either side of the element dx is equal to lighter shaded area under the m by ei diagram integrating from point A to the elastic curve of point B. For example, we are needed to find what is the angle between A and B. Okay, this is point A and this is point B. Now what we will do in this situation? We will find the moment M by EI diagram area from point A to point B. Okay, then we multiply, we will divide these area divide by EI. Okay, so how we can find these area? These area we can easily find with the help of integration from A to B. Okay, this and M divided by EI. Okay, so this equation from the basis of first moment area theorem. With the help of this theorem, we can easily find the slope and deflection of the beam. Now we are coming toward theorem number 1. The change in slope between any two points of the elastic curve equal to the area of M by A diagram between these 2 points. Okay. For example, this is the beam, simply supported beam. If we apply some amount of load on this beam, so the exaggerated curve, the deflected form of the beam will be in the form of this curve. You can see here the beam will be deflected in the form of this. So this is point A and this is point B. We shall draw a tangent line on point A and point B. Okay, this is tangent A and this is tangent B. So the theta between tangent A and tangent B is called theta BA. Okay, but in this theorem, our target is to find the theta BA. So how we can find this theta BA? We can take the area of from B to A in M by EI diagram. Okay, so this will be equal to theta BA. Okay, the notation of theta B is referred to the angle of the tangent at B measured with respect to tangent A. From proof, it should be evident the angle measured counterclockwise from tangent A. Okay, you can see here in this diagram. I will zoom it. You can see here this angle is measured clockwise from tangent A. Okay, and the answer should be in the form of radians. Now I am coming toward explanation of this theorem. The second moment area theorem This is the first moment area theorem. Okay, let the second moment area theorem, based on the relative deviation of the tangent elastic curve, greatly exaggerated view of the vertical deviation dt. Okay, now we are coming toward what is the vertical deviation or vertical displacement of this beam after applying the load. Okay, so how we can find? We will find the area of the moment m by I area, and then we will multiply the centroid of this area with the along this point in which we are required to find the displacement and deflection. For example, you can see here tangent AB. For example, we are required to find the deflection between tangent A and B. Okay, so first of all we will find the area. Okay, and then we multiply centroid. For example, the maximum deflection of the beam will occur at this point. We shall be multiplied for point A to the centroid of this area. So the centroid of this area is occur in this location. Okay, so we will multiply x bar with these areas. You can see here in this formula, tangent A divided by B will be equal to x bar of integration of AB m by EI into dx. Theorem number 2. The vertical deviation of the tangent at point A on the elastic curve with respect to tangent extended from together point B equal to the moment area under EI diagram between two successive points. This moment is computed about point A, the point of the elastic curve where the deviation of tangent AB is to be determined. Okay, you can see here, this is the tangent A, this is tangent A, and this is tangent B. So we are needed to find, if we are find tangent AB, so this deflection will be equal to tangent AB. If we find tangent BA, so this deflection will be equal to tangent BA. This is the elastic curve, or also we can call exaggerated curve. Okay, you can see here in this diagram, this is the elastic curve of the beam. If we are to find the displacement or deflection of the beam at that point, okay, so how we can find? We can easily find with the help of this formula. Integration of the area. Integration means that we will find an example. We cannot apply integration in example. We simply find the area with the help of area formula. For example, in bending moment diagram, when the area is triangular or rectangular, so rectangular area we can easily multiply width and length of the area, and triangular area length and height of the triangle, then multiply divided by 2 or multiply 1 by 2. Okay, now we are coming toward what is the procedure for analysis. If a beam is given in the question, so how we can analyze this beam and what will be the procedure of this. Okay, so the following procedure provide a method that may be used to determine the displacement and slope at point and the elastic curve of beam using the moment area theorem. Okay, so first of all we are needed to draw a M by EI diagram for the given beam. For example, first of all we are determining the support reaction. Okay, if you don't know about support reaction, so kindly watch my video of engineering mechanics. In engineering mechanics lecture, I have explained in detail, and 10 years detail I have explained that how we can find the support reactions. Then we draw M by EI diagram. M by EI diagram means movement diagram. First of all we are find the shear force diagram, and then we will draw the movement diagram. If the beam is loaded with the concentrated forces, the M by E diagram will be consist of series of straight segment and area. Their movement required to moment area theorem will be relatively easy to compute. So we will find the every type of movement, and the little explanation will be given in the movement diagram. If the loading consists of series of concentrated forces and distributed load, for example, if the given load is distributed from R in UDL or in point load, so it shall be converted into the point load, and then we will draw shear force diagram and moment diagram. Then we are coming toward the elastic curve. From the elastic curve we will know that what is the tangent line what is the deflection at that point, how we can find the deflection. So we will draw a detailed exaggerated curve. Okay, draw an exaggerated view of the beam elastic curve. Recall that point from zero slope occur fixed support and zero displacement occur at fixed support, pen and roller support. We also know that at fixed support the displacement or the slope will be zero. Okay, and pen support or roller support, the slope will be occur here in this point. Okay, it becomes difficult to draw a general shape of elastic curve. Use M by EI diagram. Realize that when the beam is subjected to a positive movement, beam curve concave up. Okay, where negative movement bending the beam concave down. Okay, if the bending moment diagram are positive, so the exaggerated curve will be downward. If the beam movement is negative, so the exaggerated curve will be upward of the beam, because when the bending moment diagram is positive, so the load shall be downward. Due to downward load, the beam will be deflect downward. Okay, if the exaggerated curve or M by E diagram negative, so the load will apply from downward to upward. Okay, so the beam will be deflect upward. The displacement slope to be determined should be indicated on the curve. Since the moment area theorem apply only between two segments, attention should be given to which tangent should be constructed so that the angle and the tangent at the point unknown slope and displacement at the support should be considered, since the beam usually has zero displacement or zero slope at supports. Moment area theorem. Apply theorem 1 to determine the angle between 2 points and theorem 2 to determine the vertical deviation between these tangents. For example, in the question, if we are required to find out the slope or angle between two successive points, then we are applying the theorem number 1. If we are required in the question that find out the vertical deviation or the vertical displacement between 2 points, then we apply theorem number 2. Okay, realize that theorem number 2 general will not be to displacement at point elastic curve when applied properly. It will only give the vertical distance or deviation between two tangents. Okay, for example, tangent A and tangent B. After applying theorem number 1 or theorem number 2, the algebraic sign of the answer can be verified from the angle and deviation indicated elastic curve. For example, if the answer come in negative, so it means that the deflection or the slope deflection is downward, and if the answer is coming positive, so it means that the slope is clockwise. If the answer is negative, so it means that the deflection is positive. Sorry, if our answer in the form of slope comes in negative, so it means that this is the clockwise rotation. Okay, if the answer is come in positive, so it means that the slope angle will be counted anti-clockwise. Okay, so this is the short discussion of moment area theorem. If you have any question, feel free to ask, and I will also give you example and detail on the board in the coming lecture. Okay, thank you.